In the grand theater of the cosmos, there is an order to the performance: gravity, fusion, thermodynamics. These are not merely suggestions. They are the ironclad laws that govern the birth and death of stars. We believe we understand these laws. A star is born, it burns its fuel, and it dies. The mass dictates the fate. It is a clockwork universe. Predictable, elegant, until it isn't. Deep in the dark, we have found rebels. Anomalies that defy the standard models of stellar evolution. Objects that violate the timeline of the universe itself. The star that survives its own execution, and the star that appears older than the Big Bang. These are the impossible stars. Let us begin with the corpse that refuses to stay dead. We travel to a binary system, a cosmic dance between two stars. One is a white dwarf, the core of a dead star, a diamond the size of Earth, packed with the mass of the sun. It is a stellar vampire, stripping material from its companion, greedily accumulating mass. Physics tells us how this story ends. This is the prelude to a Type Iax Supernova. Once the white dwarf consumes enough matter to approach the Chandrasekhar limit, roughly 1.4 solar masses, the pressure becomes untenable. In a standard event, carbon fusion ignites a detonation wave, a supersonic shock that unbinds the star entirely. Total annihilation. No remnant remains, just an expanding cloud of iron and ash. That is what should happen. But occasionally, we witness a Type Iax event, a zombie star. Here, the fusion ignition does not trigger a detonation. Instead, it triggers a deflagration. Think of the difference between a bomb exploding and a log catching fire. Deflagration is a subsonic burn, a turbulent, churning flame front that fails to generate enough shock to tear the star apart completely. It suffers a thermonuclear runaway, ejecting half its mass, glowing with the brightness of 100 million suns, but the core survives. It is left behind, a battered, hypervelocity remnant, hurtling through the galaxy. Not quite alive, not quite dead. A piece of shrapnel from a failed suicide pact. A zombie star wandering the dark. From the undead, we turn to the eternal. We look toward the constellation Libra, roughly 190 light-years from Earth. Here lies HD 140283. At first glance, it is a subgiant, moving at incredible speed through our galactic neighborhood. But when astronomers first calculated its age, the math returned a number that broke the universe. The universe, according to our most precise measurements of the cosmic microwave background, is 13.8 billion years old. Yet, initial observations of this star suggested it was 16 billion years old. A child cannot be older than its mother. An object cannot exist before time itself began. This is the Methuselah Star. How do we date a star? We look at its blood, its spectra. We look for metals. In astrophysics, any element heavier than helium is a metal. The early universe was pure hydrogen and helium. Heavier elements, carbon, oxygen, iron, were forged later in the hearts of dying stars and supernovae, then scattered to seed the next generation. Our Sun is a population 1 star, rich in these recycled metals. Methuselah is a population 2 star. It is incredibly metal poor. Its iron content is less than 1% of our Sun's. This purity indicates it was born at the very dawn of creation. So does it break physics? No, it tests our precision. In 2013, using the Hubble Space Telescope, we refined the parallax distance and luminosity. We also accounted for higher oxygen abundance in the star's core, which speeds up stellar evolution models. The revised age came down to 14.46 billion years, still older than the universe. Until you apply the uncertainty margin, the error bars are plus or minus 800 million years. The math allows the star to be roughly 13.7 billion years old. It fits, just barely, within the age of the cosmos. It is not a paradox. It is a relic. This star formed mere millions of years after the Big Bang. It has watched the entire history of the Milky Way unfold. While other stars have lived and died, Methuselah remains.